Good afternoon, guys. We are going to finish chapter 6 plus 7 plus 8 today. Uh, Lecture part. Okay, the tutorial we will have yesterday. We will look at the questions from these chapters. I think from 6 we have already seen 7. One question we discussed, and the rest we can discuss, and actually 8 also we will discuss. Okay, if needed, we can have the next week as well. But we got the idea basically, yeah. And we looked at earlier the triangular element, the quadrilateral element, the isoparametric element. Now we are talking about the triangular element, but the isoparametric element, right? So, and we defined like any arbitrary triangle we mapped into xi1 and xi2 system, right? Where if you have x1, y1, x2, y2, x3, y3, and mapping it to 1, 1. Actually, here so 1, 0, 0, 1, and you can relate basically. The rest is how you basically scale it. This is also important, as I said earlier, that you can integrate it easily. That's the main advantage with it. Yeah, and also you can also set up the higher order element easily. Okay, so we will look at that also. But just looking at this simple transformation, now we already have, we said x xi1 xi2 is a function of this, how this x, we call it xi I multiplied by, this is like n basically, right? Multiplied by xi. So I equal to 1, 2, 3, and x y xi1 xi2 is equal to summation, because j equal to 1, 2, 3, right? Xi j y j. Okay. This you could do, and you can see, because in a way this is also that ni xi1 and xi2 is equal to ni. So this is our transformation, and you have number 1 node goes here, number 2, and this is 0, 0, which is number 3, and ni, like n1 is xi1, n2 xi1 xi2 is equal to xi2, and n3 xi1 xi2 is equal to xi3 equal to, actually you can also write xi3 which is equal to 1 minus xi1 minus xi2. Yeah. So this we know, and based on that you can transform it very easily. Yeah. And what do you have to do? Finally, the original equation remains the same, and everything as we did for isoparametric element, for quadrilateral element, same kind of thing we can apply. We know that k is equal to a small k b transpose b d omega, or this is for isotropic element. Yeah. And finally we have to find out b, and b matrix as you know, is equal to del n1, del x, del n2, del x, del n3, del x, del n1, del y, del n2, del y, del n3, del y. Right? So we know this is, we have to find out k, the big K I'm talking about, which will be 3 by 3 matrix for a triangle. And only thing is we have already solved this problem, but we are approaching with a different method, right? So that you can also extend further. So this is isoparametric. We are making isoparametric tabular element, or we are using the tabular coordinate system. Triangular coordinate system. Actually, you also call it triangular coordinate system. We understood that because we have xi1, xi2, and xi3 concepts, right? Where xi3 is equal to nothing but 1 minus xi1, xi2. We have to find out this, and we will use the same method as we did earlier. And you remember del ni, del xi1, del ni, del xi2 is equal to, and del x over del xi1, del y over del xi1, del x del xi2, del y over del xi2, right? And here you have del xi1, del n I over del xi2. Exactly the same thing you got, right?
Sorry, x.
Oh, x and y. Sorry. Should have x and y. Yeah, so we got it earlier also. The same thing you will do, and you know that already. In order to find out this, you have to invert it, and you call this one is as a J. Right? This is again the Jacobian matrix. So you get del ni, del x, del ni, del y is equal to Jacobian matrix, del ni over del xi1, del ni over del xi2. Yeah. Okay. Any question, guys? Okay. Now, J you can find out very easily, and since you have x and y expressed in terms of xi1, xi2, and J being this, you can find out very easily, right? As you did earlier. So I'm not explicitly writing it. You do this operation to find out this. Once you find out these values, you put here, you can find out the B matrix, then you multiply B matrices here, and you find out K. You have to, only thing now is you have to integrate. And what you have here is let's call it function f, xi1, xi2. So everything will be in function of xi1, xi2 now. But now we have to look at what is d omega, right? D omega. Now again, you can see the system you had here where you have x1 and xy system. This is x, this is y system, and you have here xi1, xi2 system. So you can do exactly the same analysis, and it is equal to d is the determinant of Jacobian, and d xi1, d xi2. You can write the same. Okay? Right? Here also you have done the exactly same thing. You have done some stretching, and also the angle has been twisted. So the shape you have changed, and the size also you have changed. So it relates the similar way as you did in case of the quadrilateral element. Right? So exactly you get the same thing. Yeah, and then rest is, let us say if you are going to some function, let's call it g xi1 xi2. Yeah. Okay, so here let's write k is equal to this small k becomes b t b, and instead of d omega you have j d xi1 d xi2. Rather, let's write z xi2 and z xi1, and we have to integrate accordingly. And you can see how you integrate here. If there is any function f defined here over this one, so you also have to integrate this way. So what you see here is from here to here you have d xi1. This is from here to here d xi2, and then this is, what is this line? Right? This line is xi. Xi2 equal to 1 minus xi. Right? So basically, d xi2 here, this one you are integrating first, so it goes from 0 to 1 minus xi1. Then it gets 0 to 1. So this is what it is, right? Yeah. So this whole thing will be a function that is called g xi1 xi2. This will be a function of xi1 xi2, including j itself, because you can see that this is j, right? You can use the usual integration. For his limits goes from 0 to 1 minus xi1. You can do it this way also. Or you can use what is known as Gauss quadrature for triangle. Yeah, triangular, right? Or you can call it triangular Gauss quadrature. Right? So anyway, so this one basically what it says that any integration over a triangular region. Let's say if you have f xi1 xi2, right, and you have similar kind of thing, right? So what it means is if you have this integration, here it goes 0 to 1 minus xi1, then 0 to 1, and then you have a function here, and then you have d xi2, d xi1. For that, also you can write it as a summation of I equal to 1 to number of Gauss points, and wi, right? Wi, and then you have f xi1i means xi2i. These i's are not power; these are indices to identification, right? So this is a point number 1, point 2. Right? Signifies the Gauss Gauss point number. Gauss point number. Okay? So you can directly use this way. You don't have to double integrate what it means basically. So example will be number of Gauss point will be equal to 1. Yeah. Then weight W1 is equal to half. The points xi1 equal to xi2 is equal to 1 over 3. So basically like this. So you have 1, 0, you have 0, 0, node 1, 2, and 3. And you can see that, let's say you have this kind of region where you have to integrate some function. Let's say function f xi1, xi2 equal to a constant, right? Let's call this is a just 1, meaning that I just want to find out what is the area of the triangle, right? You are integrating over it, means what is the meaning of that? If you have double integral 0 to 1 minus xi1, 0 to 1, and then you have 1 here, and then if you have d xi2, d xi1, is it equal to what? Area of the triangle, right? So you should get area of the triangle. Yeah? You should get that, right? And let's see, what is the area in this case? Half times 1 times 1. Right? So yeah, so expected. And use the Gauss quadrature now, right? So if you use Gauss quadrature, this rule, then what you get? You get, this is I. I is equal to W1. W1 is half multiplied by F. F where? 1/3 and 1/3. So it is like here. Okay? So 1/3 and 1/3, which is equal to 1 only, because if this is 1, so you get half multiplied by 1. So you get the answer. Yeah. Okay, so and this is valid for when you have a linear term, right? Meaning that if this function has the order of f xi1, xi2 has the order of 1. So if it's a planar, so it may be alpha xi1 plus beta xi2 plus gamma. If this kind of thing, then it will work. If it is higher, it will not work. Right? So, of course, there are some mathematics involved, but as far as your syllabus is concerned, we don't go deep into that. Okay, so this is given. You can use the chart basically. Okay. For NGP, number of Gauss point 3 equal to 3, then it will be something like this. There are various possibilities, not just if there's number 3, there are at least a couple of ways. One is half and half and half. These points, one of them. Yeah, and meaning that in this case, so W1 over W2 over W3 is equal to 1/3 of half, so it becomes 1 over 6. And xi1, xi2, that's the first one. So xi1, 1, xi2, 1 is equal to any of those. So 1, 2, 3. So let's say start from here. So we'll say this is half and half. Xi 1, 2, xi 2, 2 is equal to, will be this one. So 0, half. Xi 1, 3, xi 2, 3 is equal to half. This one. Okay. And so on. Okay, you can refer to your book for higher orders. Yeah, those are just numbers only. But main thing is understanding how it works. Right? So, yeah. Any questions so far? Okay, you understand the advantage of converting any arbitrary triangle into isoparametric element and working like that. That will automatically make sure that you can integrate very easily, right? Because you can apply the Gauss quadrature within that. Yeah, so that's why it's a good thing. Okay. Any question? Remember, all these elements we are going to use for different problems also. Different problem means right now we are looking at the scalar field problem where every point has only one variable like temperature changing. Right? In case of difficult problem, you have the concentration. Right? When we go to vector field problem, then we will have the displacement, right? For elasticity problem, plane stress problem, it will have displacements in x direction and y direction, even z direction if you see the 3D. So there also we will use the same kind of element in 2D, but the formulation will be a bit different because you have to make sure that our formulation will be such that we can solve and can find the vectors rather than scalars. That's the one thing. Okay. Now, given this, now you can think about the higher order elements, and higher order elements will be something like, sometimes what happens? You have some surface like that. And there's a plate, let us say, it goes like this, and you have to model this. Now what happens? Of course, you can go take very small elements like this so that it follows the curvature, right? Triangle element like this, and you can do it like that. Other way is you should have the element itself, which will be something like this, right? Like you have the three elements like. What you see is the edges are curved. Right? So accordingly, also you can go to higher order elements, in which what you do, you have some defined element which has a triangle, which is something like this. So you have a triangle, and between that you have a point like this. Edges itself are curved. Edges are quadratic to begin with. And this you can map to triangular elements like this. Okay? So you have like this. and then you have here, here, here. So let us say you have 1 and 2 and 3. Then you have 4. So let's call this 4. Then you have 5 and 6. So here, as you have done earlier, this will be 1, this will be 2, this is 3. Front of 1, we have 4, and 5, this is 6. Again, this is xi1 system, xi1, xi2. Okay, guys, one thing I forgot here to also mention that there is also a formula that you can use that is quite handy. That if you have this kind of system I, which is equal to 0 to 1, 0 to 1 minus xi1, and you have a function f xi1, xi2, not a function, but let us say you have now xi1 to the power I. This is different I though, okay? Okay, let it be clear anyway. So xi1, xi2 to the power j, and xi3 to the power k. Yeah, so d xi2 d xi1. Okay, so where I, j, k are numbers. Right? I, j, k are natural numbers basically. Okay, if you have this kind, because in polynomial you will get this kind of thing only, mostly. Yeah? If you are using polynomial, you will get a power in terms of power only. Either it will get 0, meaning that the natural number, okay, does it include 0? Huh? So, positive whole numbers, what do you call it? Integers, positive
Natural whole numbers.
equal to 0, 1, 2, 3, okay?
Whole numbers.
Call it whole numbers. But in that case, what about the negative? Negative numbers are not whole numbers. It has been ages since a JE days, so I don't remember guys. Anyway, so I, j, k are 0, 1, 2, 3, 4. These are whole numbers. And then I, how do you find out the I? I will be is equal to, and the formula is, you can use the formula I equal to I, j, k divided by I plus j plus k plus 2. Yeah, and then you have area of the triangle. Two times area of triangle. Sorry, 2 times area of the triangle. So let us say it's 1, right? So I equal to 0, j equal to 0, k equal to 0. So 0 factorial, 0 factorial, 0 factorial divided by 2 multiplied by 2 times the area, right? So okay. Any question, guys? Okay, so this is also handy. You can use that. You know that in this case, xi3 is equal to 1 minus xi1 minus xi. There. Okay. So coming back to this, here we have you can formulate now, and we have x1, y1, x2, y2, x3, y3, and so on. So you have x4, y4, x5, y5, x6, y6, and similarly here you can have this 1 0, then you have 0 1, you have 0 0, you have half, 0 half. This one is half 0, you have half half. The mapping like that, right? We are just understanding the how you do it basically. What is the advantage? You can capture the geometry very nicely. That's the thing, right? And sometimes very important without using large number of elements. There you can write similar way that x xi1 xi2 is equal to summation of ni xi1 xi2 and x. Right? So I equal to 1 to 6 now, right? Similarly, y xi1 xi2 is equal to I equal to 1 to 6 ni, or doesn't matter, can use I also z. Z, xi1 xi2, yz. Only thing is what the values of these shape functions. Yeah? And shape functions here you can see now how to define. You can define very easily now. How? You can define very easily. So there is a line here which is going like this. There is a line here. And there is another line. Goes like this. Okay. This one is what is the equation? This equation. I mean the line. Which line is this? This line is, or in other words, xi3 equal to 0. Right? Or this one is xi3 is equal to and similarly you have for others. So this guy is xi1 equal to half. Yeah? And this yellow one is xi2 equal to half. Or half. And this is xi2 equal to 1. What is this line? This line is xi2 equal to 0. This is xi3 equal to 0, and this line xi1 equal to 0. And it works. It works why? We will see how this will help you in finding out the shape function. So n1 xi1 xi2 is equal to n1 is where? This one. How do you find out? How to find out now? Yeah, this node.
we can take Xi1 equals 1 by 2, Xi1 equals to 0. 2 lengths.
Say again, Xi1.
Xi1 equals to 1 by 2, Xi1 equals to 0.
Yeah, fine. So it will be some alpha multiplied by Xi1 multiplied by Xi1 minus half. Right? This is what it will be. Yeah. So you can put the value of 1 0 there. So n1 1 0 is equal to alpha, and you have 1 multiplied by 1 multiplied by 1 minus half, so it becomes equal to half. Has to be equal to 1. So alpha is equal to 2.
Which one? Sunil Kya Sharma, Prince Iraq's Photo Studio, or Pragati Amera 2, 11th floor vegetables and fruits.
Siri. I don't know how you activate it. AI has its own problem. Okay, so okay, now alpha is equal to 2, and this is hence n1 1 0 is equal to 2 Xi1 minus half.
That will be n1 Xi1 Xi2. Last one.
Say again.
n1 Xi1 Xi2 equals to 2 Xi1 Xi2. But where we have written 1 comma 0, there should be Xi1.
Oh, acha, that's yes. Xi1. So Xi1 Xi2. Correct. We are going to use this space as well. So what is n2? Let's find out n2. It will be same as that, yeah. So will be equal to 2, probably, right? And Xi2 minus 1. Yep. And similarly, you can find out n3 Xi1 Xi2 is equal to what?
Sorry,
That will be
minus half and
Xi3 minus
Xi3.
half and Xi3 minus half.
2 Xi3
Xi3 minus half.
Xi3 minus half. You can just write like that. Yeah, so it will follow automatically. Here also you can see that this is Xi3. Yeah, multiplied by Xi3 minus half, and accordingly it will work. Yeah, so you can do like that. Now n4 Xi1 Xi2. So what is n4? This one.
So Xi3 Xi2. But we put it in Xi2.
This line is Xi2 equal to 0. This is Xi3. So Xi2 times Xi3. Okay. So if you have the value half, so it goes what? Because if you have 4 or 2, Let us see.
0 and half.
So if you have the 0 and
Half.
half, then how it will work? It will be 0 then.
Xi 3. Okay. No,
Oh.
sir, half of that.
Yeah, right. Yes. So Xi2 is Xi3. So it will be Xi2 and 1 minus Xi1 minus Xi2. Right?
Hmm.
Here,
Half
what
into half.
it will be half only. So let's say 0 and half. Let's call it, we put beta here. So we have beta here. So N4 is 0 and half is equal to beta, and we have half 1 minus 0 minus half, right?
Hmm.
Is beta, and this will be 1/4 is equal to 1. That makes a beta equal to 4. N4 Xi1 Xi2 is equal to 4. 4 Xi2 Xi3, you can write like that. Yeah, and similarly you can write extend. Good thing about this is symmetric about all those things. So you can write N5 Xi1 Xi2 is equal to, we have N5 here, 4, and then what?
Xi 1, Xi 3.
So Xi1 and Xi3. And N6
Xi 1.
will be equal to Xi4, Xi1, Xi2. The rest you know, you can work with this. Exactly, you have to follow the same way. Yeah? The values will be here, since there are 3 of them. So accordingly, J, you have to find out the transformation is taking place from here to here. So the B matrix you can find out. B matrix in case will be, what will be the size?
Equal 3.
A equal to
6.
GTB, right? Where you know B will be
2
2 by 6. That's only difference. Yeah. Del N1 over del X, del N2 del X, till del N6 over del X, del N1 del Y, del N2 del Y, del N6 over del Y. Okay, rest is here. This is also XY system, and here you have Xi1 Xi2 system. All the other things remains the same. Okay? So only thing is these values are going to load J. Jacobian will come into picture, and the meaning remains the same. So we will have del X over del Xi1, del Y over del Xi1, del X over del Xi2, del Y over del Xi2. So again, you can find out, because X is in terms of Xi1 and Xi2, so you can find out from here. Only thing is that J will have now the higher order terms will be there. That is the only difference. Okay? This higher, if you compare with the audio triangular, which was easier, you have N1 equal to Xi1. So if you take derivative, it becomes a constant. In this case, you have quadratic terms, so that will be. So what I mean to say is it will have xi1, xi2, and this will be have higher order. That's the only difference. Otherwise, everything remains the same. And then accordingly you can proceed, right? So your k as such will be equal to, finally if you look at that, so it would be 0, 1 minus xi1, 0 to 1, and the small k b, b. Again, the members of b you have to find out by inverting. Like remember the okay. So original equation ni over nx del ni over del x del n you can write like that. Ni del y is equal to, and then you have Jacobian here, and then you have del ni over del xi1 del ni over del xi2. So sorry, inverse of that, right? Inverse of that, right? This one you can find out from here. We have those equations, and then here Jacobian inverse of that you put here, you find out this. Once you find out this, you compose the B matrix, and then you put it here. B side 2, this side. Then you put. We also have the Z coming. When we converted d omega, remember we have d omega converted, so Jacobian determinant also comes into this. You have to write that also. Yeah. Then you are taking inverse of that. Then also there will be Jacobian determinant of Jacobian, right? A square of that coming basically. So that is also there automatically because of J inverse, and you have both two of them. So there will be two Jacobians multiplied, right? But it will be in the denominator. We'll be considering this numerator here, right? Anyway, the details, you got it? What I was saying?
Yes.
You got it? So all other things remain the same. So once you define this, everything is how to do. Basically, it's not must to do basically. Okay. Any question, guys? Okay. Okay. So I'm working on your homework actually. Yeah. So I will post it as soon as possible. Then we'll think about maybe since we have completed chapters 6, 7, 8, then we can have a quiz. But before that, I will post the homework this week we will do. Next week, sometimes maybe a Friday or something, I will find out which day is better, Thursday or Friday. Quiz will be the right time right now, okay? Which will be based on the chapter 6, 7, 8, 2D heat transfer, based problems. Yeah. It will be online only because the class, if you see, is not full yet. It is running in hybrid mode. Yeah. So this is we cannot change basically. Has to be like this. Well, you let me know if you think it's not fair or something. You can always tell me. Yeah, so in that case, we can also combine probably with the end semester exam. meaning that you get from there. Yeah, but as I promised, it will be a skill, so I can skill that time as far as the quiz is concerned. So it's up to you. Like if you think about it, if you want to, like as per the plan, it will go in online only. So both ways. I mean, what I'm saying is suggestion both ways, that online should be conducted in online mode or should be conducted in offline mode. But in offline mode, what happens is there will be few people who will be not here. For them, you will have to do the online. So you will be taking offline, but others will be taking online. But how to scale them, and those are the problems. At the max, if we can tell that, okay, quiz will be as a part of the ensuing exam only.
So the first year students are having complete offline, right?
Sorry.
So the first year students are having complete offline, right?
Yeah, they are complete offline because the semester is starting right now. For us, it is just 1 month remaining right now. So because of that, it was not made mandatory. Yeah, so since already started, and since this is in hybrid mode going on, so it is also like approved by the Senate that way. So we cannot change also. But the exams will be offline mode, end semester exam. That for sure. Yeah, it's okay.
Like, is it professor dependent for offline exams, or is it mandatory?
Mandatory for everybody. Offline exam mandatory for everybody. Yeah, classes are professor dependent, offline or online. If I want not to take, let us say, this class in offline mode, I would have gone with online mode. Yes. So I wanted, so I started. Yeah. Any question, guys? Yeah. Okay. Okay, then, guys. See you on Wednesday.